Ladies and gentlemen, welcome to the Quadratic Formula, brought to you by me, Mark Anderson for Kellogg Community College. And we are going to look at the quadratic formula in a way that you've probably seen it before, but maybe in some ways that you haven't seen it before. The quadratic formula's purpose is to take problems that are factorable or aren't factorable in the ax squared plus bx plus c form and figure out when the equation or parabola crosses the x-axis. So what I'm about to do is give you the formula for this, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the way that I actually teach this, it kind of comes from a pretty cool analogy of a semi-truck. The front of the semi-truck, which is drawn kind of like a boot or a misshapen Tetris piece, is where the driver, negative b, sits. The brake cable and the hitch to the trailer is the plus-minus symbol, and then the trailer is actually the square root. Now inside, if you've ever seen an episode of Storage Wars or Shipping Wars, you know you have to pack that material very nicely so it doesn't get banged around in the cabin. So I'm going to use parentheses to do that for my b squared minus 4 times a times c. Now the reason why I do that is now the items will not get damaged in transit, and more importantly, the items will, if negative, will be processed correctly by the calculator. All divided by 2a, and this I will stylistically draw like this 2 times a, so it actually looks like the wheels in the truck. But what this is going to allow me to do, it's going to allow me to speak to this problem and explain how to do the work here. Now, to basically use this formula, we would have to look at the a, the b, and the c of the problem. In this case, our a is going to be 1, because the number in front of x is a 1, or sorry, the x squared is a 1. The b is going to be a negative 2, and the c is going to be a negative 3. Now, on a side note, this first problem is factorable, which means that you can multiply two numbers to make a negative 3 and add to make a negative 2. On the side, I'm going to show you that factorization is x minus 3 and then x plus 1, and that's equal to 0. If I set each of these equal to 0 and solve for x, well, then I get two answers. I get the answer of x equals 3 and also x equals negative 1. So what this tells me is that this graph intersects at negative 1 and 1, 2, 3. These are its x-intercepts. Now, it also happens to be that this is has a y-intercept of negative 1, 2, 3. So it probably goes down, hits that negative 3, and comes back up. And the vertex would be in the middle here, roughly 2 from each direction here at x equals 1. We're going to learn more about vertex, the vertex of a parabola, whether it's a minimum or a maximum, and graphing such these and their minimums or maximums in a later video. But what I wanted to do is show you why we use the quadratic formula, or factoring in general, is to find the x-intercepts of a parabola. Because we really want to find out when it hits the ground, and you can see that the 0 is literally the ground of this problem here, where the x-axis represents 0. But I digress, because we have talked about solving by factoring, but what we're going to do here is to solve using the quadratic formula. So here I'm going to take my negative b. So notice that my b is already negative, so this is going to be positive 2, plus or minus the square root, and here's where I load up my formula, negative 2 squared minus 4 times 1 times negative 3. Now, if I use parentheses, it will help me get the correct answer because this negative 2 raised to the second power is positive 4. Now, the calculator will make a mistake if you drop these parentheses, and please put the parentheses in as good programming practice for doing these problems. All over 2 times a, which in this case is 2. In the next step, I'm going to simplify this under the square root, which I will call the discriminant. The discriminant is the contents under the square root, or as I like to call, the discriminant is another way of math to call it a trailer, or inside of the trailer, the cargo. The discriminant is the cargo. So what I'm going to do is I'm going to simplify that discriminant. By plugging that into my calculator, I get an answer of 16. And then I'm going to split the wheels up. Remember how in this picture of the truck I got the 2 and the a separated? Well, I'm going to separate that wheel over here with a 2 and a 2. And I can do that because this binomial here, this numerator plus minus other information in the numerator, makes a binomial, and I can split that up. What that's going to allow me to do, it's going to allow me to simplify this problem pretty straightforward, because 2 over 2 is 1, plus or minus. The square root of 16 is 4, and I just want to draw that there. The square root of 16 is 4, and 4 over 2 is 2. Now, in a video I made earlier, I warned that 1 plus or minus 2 is not the same thing as plus or minus 3. You should split these up since they are whole numbers and can be combined, because yes, 1 plus 2 does give you 3. Look, you can see that's where I thought it was going to land up here. And 1 minus 2 is not negative 3, it's technically negative 1. So there's my other answer up here. So my answers are 3 and negative 1, or if you want to be correct on the coordinate system, your answers are 3, 0, negative 1, 0. And that's how you do the quadratic formula. Yeah, factoring was a lot faster, I agree with you. But we are really practicing the quadratic formula here, and even if you miss the fact that this second problem here is also factorable, you can still, use the quadratic formula. A equals 5, B equals negative 25, and C equals 0. You will see that there is no number all by itself, so the C number is 0. And the reason why we use factoring and use a quadratic formula is the factoring works for only a few problems on this page, and the quadratic formula works for every problem on this page. So let's just continue using the quadratic formula and come back to the idea of factoring when we see it's applicable. But at this moment, let's just kind of progress and see where we end up with our answers here, because here we have our 5, negative 25, and 0. We are going to now put this into the quadratic formula. My negative b is the negative of negative 25, so it's positive 25. That's the driver of the truck, plus or minus the square root of negative 25 squared minus 4 times a times c, which is 5 times 0. And 5 times this is going to all make 0, and then this is all going to be 2 times a, in this case is going to be 10. Now I'm going to split this up into 25 tenths, plus or minus. I'm going to simplify the discriminant, or the items underneath the square root, which is 625 over 10, which then I can break down into 25 tenths plus the square root of 625 is 25 tenths again, plus or minus. Now you can simplify this now or later. I'm going to simplify it later. I'm going to take my 25 tenths plus 25 tenths and make 50 tenths, which is 5. So one of the places where this hits the x-axis is 5, 0. And I'm going to take 25 tenths minus 25 tenths, which is 0. So my two answers to problem number 2 is going to be 5, 0 and the origin. And you can see if you type this into your y1 of your calculator, you will see that it does hit or cross the x-axis at the origin and 5, 0. Now, some of your teachers may just want you to write the answer as 5 and 0 without writing the x-intercepts, but I'm just showing you where you could, or how you could represent your answer. But I'm sure a lot of your professors or teachers who are teaching this to you would be just happy enough to see the work and the 5 and the 0. Well, we've got 6 more problems to go, and this third problem, like the first two, is factorable again. And that factorability can mean that you could do the problem much faster than the quadratic formula. That is one of the benefits of factoring. It is a lot faster. But the benefit of doing the quadratic formula is that it always works. In fact, we'll see it later on in another video when we work with imaginary numbers. So now what I'm going to do is I'm going to take my a, my b, notice there's no c, so c was 0, and here's my driver, plus or minus the square root of b squared minus 4 times a times c, 1 times 0, all over 2 times a, in this case it's 2. So what I have is 25 over 2 plus or minus the square root of 625 over 2. I'm going to simplify that, and you'll see that this again makes 25 halves plus or minus 25 halves. And so if I add this up and just consider the plus possibility, because these are two separate answers, one where there's a 25 halves plus 25 halves, and the other half which is 25 halves minus 25 halves, which is going to be 0. So I know it's going to intersect at 0 from the second piece of this here, but the first piece where I go 25 halves plus 25 halves is 50 halves, which I can simplify to 25. So my answer for this problem is that this graph will hit the x-axis at 25, 0 and at the origin. Now, if you try typing this in on the calculator and hitting graph, you're not going to actually see 25, 0 unless you change the window to go wider, because the window is generally set at 10 maximum. So the table would get you there too. If you scroll down to 25 on the table, you will see that it will be 0 again. Well, this is the third problem, and again, this is another factorable problem. I could have factored out an x in this first part of the problem and solved it that way, but I'm choosing to use the quadratic formula. Now, for this problem, this is not factorable. The two numbers to multiply to make -2 cannot make -2. -2 can make, if I take the factors of -2, which is 1 and -2, or -1 and 2, those will not add to make this. So I'm stuck using the quadratic formula. This is going to be the only way I can do it if the problem is unfactorable. I know in previous lessons you may have thought, oh, it's prime, but in fact it does cross the x-axis. It just doesn't do so at a whole number or any kind of rational that you could have figured out. So the driver is 2, because it's the opposite of b, plus or minus the square root of -2 squared minus 4 times 1 times -2. Extend my square root all over 2 times a, which is 2. Well, this is going to make my first part of the truck 2 over 2, plus or minus. If I simplify my discriminant, which is the cargo under the square root, I get 12 over 2. So this gives me 1, because 2 over 2 is 1, and the square root of 12 can be broken down, knowing our properties of radicals, as the square root of 4 times the square root of 3. The square root of 4 times the square root of 3 is another way of writing 2 square roots of 3. So 1 plus or minus 2 square roots of 3 over 2. The 2's simplify because you can divide 2 divided by 2 in a fraction. So 1 plus or minus the square root of 3 is the answer to the problem. Now, to explain what that means is going to take probably a little technology. Remember, our answer was 1 plus or minus the square root of 3. And to show you this, I'm going to grab a graphing calculator and put it on the screen, but I need you to write down or remember that the answer to this problem was 1 plus or minus the square root of 3. So let's actually take a look at a graphing calculator now. 1 plus or minus the square root of 3. Okay, so let's type into our calculator 1 plus the square root of 3 and approximate that with a decimal. And that answer is going to be roughly 2.73, or almost a 3. Then we're going to go 1 minus the square root of 3, and you'll see that this will give us a negative number, and that negative number is going to be almost to -1, or negative 0.73. Now I want you to remember in your head positive 2.73 and negative 0.73. Now if I go to my calculator and type in to the y equals x squared minus 2x minus 2, the purpose of doing the quadratic formula is to show where the equation is crossing the x-axis. And remember when we decimalized this problem, we got these two decimals, 2.73 and negative 0.73. So almost a 3 and almost a -1. Well, let's look at the graph. See, the graph almost gets to -1 and the graph almost gets to -3. So it may be a previous lesson you thought, oh, that thing's prime. It's prime from the idea that you can't use a rational number to factor this, but using the quadratic formula, you can come up with its zeros, its place where it crosses the x-axis, and it does so quite spectacularly here. But as an answer, how would I write that down, right? Well, let me put the calculator away here and get back to writing on the screen. My John Madden-like pen here. So the answer, without any kind of, because what we did is we showed you the decimal of 2.73, 0, and negative 0.73, 0, but this would be 1 plus the square root of 3, 0, and 1 minus the square root of 3, 0. That would be an equivalent way of showing those two answers. This is an approximate answer, and this is the exact answer. So the difference between really Algebra 2 and trigonometry in terms of the level of specificity. All right, wow, that was quite the explanation, right? Luckily, these next two problems here will go much faster because we're just going to use the quadratic formula. A equals 1, B equals 5, C equals 3. This is not factorable because you cannot make two numbers to multiply to make 3 and add to make 5. But this does have two irrational zeros for where this hits the x-axis. So negative 5 plus or minus the square root. Let's load up the trailer with the discriminant. 5 squared minus 4 times 1 times 3. All over 2 times a, which in this case is 2. If we split this up, we've got negative 5 halves plus or minus the discriminant. If I type that into your calculator, the discriminant is 13 all over 2. And we're done. Yeah, we're done. Because you can't actually take the square root of 13, and I mean, you can make it a decimal, but you can't break it down any further. The square root of 13 is a prime number. 13 is a prime number, and under the square root, you can't make it into anything else other than that. So that's your answer. And again, you could approximate this on the calculator by typing in negative 2.5 plus or minus the square root of 13 over 2, or plus square root of 13 over 2, then get a decimal, then negative 2.5 minus the square root of 13 over 2, get a decimal, and you can get the approximate answers of when the x will hit, the parabola will hit the x-axis. All right, let's do the next problem. Hey, spoiler alert, this is factorable, but the numbers are so big, I don't want to factor it. Gee, and that's the thing. You can kind of abandon factoring, and I would do so on some of these tricky trinomials, because you could multiply 9 times 16 and try to find the combo to make negative 24, or, I mean, the guess and check will just take a long time. And this is a situation where the quadratic formula, by doing the negative b plus or minus the square root, in this case, this is our b squared, don't forget the parentheses here, minus 4 times a times c, all over 2 times a, which in this case is 18. This is a case where typing all this in will actually be faster than trying to factor, and look what I get, 24 plus or minus the square root of 0. Oh, nice, the square root of 0, all divided by 18. And plus or minus 0 is the same thing as 0, so it's 24/18 or 4/3. This only has one answer at 4/3 comma 0, where it hits the ground. Now at this moment, some of you may have been a little upset when I said that this is a real tough problem to factor, because it actually isn't. This fits a pattern where the square root of 9x or squared is 3x, and the square root of 16 is 4, and it just so happens that 12 and 12 make negative 24, so you could have factored this pretty quickly and got the answer of 4/3 if you set 3x minus 4 equal to 0. But, you know, here's the thing, guys. On the test, you may not want to go through all of this alternative strategy for factoring. You probably have had the quadratic formula enough. You feel pretty secure in doing it. So, I mean, do use whatever method you want, but you do have the time constraints of the test, and you do have, you know, best practices. I would probably not expect you to see this factoring pattern, but I would totally expect you, to remember this factoring pattern up here, this easy trinomial here. Now, again, these bottom two problems, the last two we're going to do here, they're factorable too. Yeah, these are two factorable problems, but again, the numbers are so big, we will probably not have you factor them. I will also say that you have to, upon looking at them, you may want to not write down your A, B, and C numbers until you get the problem written correctly, because this problem is not written with the 2 on the correct side. So if I subtract 2, now I have my A, my B, and my C. And over here, I'd have to move the 72 to the other side. There we go. And that problem now is solvable. A is 3, B is 50, and C is negative 72. And yes, both of these problems are factorable. I promise you, both of these problems are factorable. But the thing is, these numbers are so big. At least this problem is 3 times negative 72 to make a 50. What? You're better off just, doing the quadratic formula. So let's finish these two problems and call this video done. So there's my driver, negative 7 plus or minus the square root of our b squared minus 4 times a times c, all over 2 times a. In this case, that's 30. So I've got negative 7 over 30 plus or minus, and if I do my discriminant, I get another positive answer of 169, which is perfectly rootable, divided by 30. So the 169 square rooted is going to be 30. Sorry, not 30, 13. Shoot. There we go, 13 over 30. And so now we have two possible answers. Negative 7 plus the 13 is going to be a total of 6 over 30. And the negative 7 minus the 13 is going to be negative 20 over 30, which this can simplify to 1/5, and this can simplify to negative 2/3. So would you believe that this problem intersects at 1/5, 0 and negative 2/3, 0, which means about 0.2 and a negative 0.6 repeating. So it actually sticks pretty close to home, or sticks pretty close to the origin, with a very tight parabola. On this problem, let's put my driver as negative 50 plus or minus the square root of my 50 squared. Again, use the parentheses to make sure you get the problem right. Minus 4, that's a minus, not a negative, minus 4 times A times C. And if I misspoke and called that a negative at any other time in this video, I apologize, because it is a minus problem. It is a minus of subtraction, and using a negative symbol on the calculator will give you a different answer. So this is minus 4 times 3 times negative 72. All right, all over 2 times A, which is 6. All right, let's divide the wheel up here, negative 50 over 6, and that negative 50 over 6 plus or minus the square root. In the discriminant, we've got a big old 3,364, all divided by 6. But the 3,364 is dividable. It is a perfect root. Anytime you get numbers bigger than 144, just try taking the square root. It'll probably work out, and it does work out to 29 over 3. All right, so wow, 50 over. Oh, wait, not 29 over 3. Ah, shoot, I simplified too far. 58. I simplified one step too fast. 58 over 6. There we go. So I've got negative 50 over 6 plus 58 over 6, and you can see that if I take the positive strategy, I get 8 over 6, because negative 50 plus 58 over 6 is 8/6, which is reducible to positive 4/3. So this hits the x-axis at 4/3, 0. Now if I go negative 50 minus 58, I get negative 108 over 6. And negative 108 divided by 6 is a perfect answer of negative 18. So the other place where it hits the x-axis is negative 18, 0. And those are my two answers to this problem. Yes, this problem was factorable. It totally was factorable, but we are not going to look at things that's big, and this is a situation where the quadratic formula helps us out with these really, really tricky trinomials to find the answer where the parabola crosses the x-axis. And I never seem to know how to finish these videos, so I'll just say thank you for watching, and good luck with this section, and thank you again. See, can't finish these well. Good night.